The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Good morning, good evening, good day to all of you from wherever around the world you're joining us. Welcome to our annual ritual here, the What's New webinar. This is an open webinar. We got a lot of people signed up, so we're pretty excited about this one. As mentioned, we're going to be talking about the what's new in our upcoming release. Our special welcome to all the people who are joining us for the first time. Welcome again. And then for people who are joining us, who've joined us before, thank you for your continued patronage. We hope to see you again in other webinars down the road. For those of you who don't know me, I'm Joe Anand. I'm the product manager here at MecSoft for all the products that we're going to be showing today. And today I'll be joined by Don LaCourse, our support manager, and he's actually going to be doing the demo and the show and tell. Before we get started, there are a few rules for the webinar. So Don, next slide, please.
Yeah, we didn't skip that one slide. Go ahead and go over them now.
Yeah. Okay. So there should be a chat window where you can add your questions in there, since there's a lot of people registered, and we'd like to restrict the webinar questions to what we're showing. Anything apart from that, unfortunately, we don't have time to cover. So anything that Don is showing or I'm talking about or Don's talking about that you're not clear, please go ahead and put your questions in that chat window that you see. And I'll be watching in the background, and we'll get to those answers to the questions as soon as possible. And if necessary, we can stop the demo and show something in more detail. And also, as usual, we will be sending out the cleaned up recording of the webinar to everybody who's registered. So give us a couple of days and look for that email in your email. Make sure it's you check your spam folder also for those people who are joining us for the first time. So today's topic, as mentioned before, is what's new in 2025. So basically, we're going to be going through all the things that we've been working on in the product for the entire year of the 2024. We're going to be starting with the 2.5-axis milling enhancements, 3-axis, talk about 5-axis hole making, simulation enhancements, usability, and post-processing and SDK enhancements. These are some of the things that we wanted to highlight. Obviously, there's a lot more enhancements all covered in the What's New document that is on our website. If you go to our, we will actually be also sending you a link for the What's New document that you can take a look after the webinar is over. So I don't really want to go into the topics here in this slide because Don's going to be talking about each one of those independently. So without any further ado here, Don, go ahead.
Okay. Hello, everyone. Thanks for joining us today. As Joe mentioned, we're really excited about this 2025 update, and we've got a lot to talk about. So let's just jump right in here. And Joe, if you got anything to add, obviously just stop me. And
sure. Yeah.
Okay, so we're going to start with 2.5-axis milling, and the part that we see here, the main thing we added, well, one of the things we added is cutter compensation for hole pocketing and profiling. I did just want to mention that if you have a hole that you need to cut and you need very tight tolerances, up to 6 or even higher if you need it, hole pocketing and profiling is the way to go. You can get very tight tolerances, like if you got a press fit or a loose fit, say of a bearing or a sleeve or something. This is the method you want to go to. And now that we've added cutter compensation, it makes it even better. If you're cutting production holes or just if you want to use the compensation feature in your controller. But we've added cutter comp for hole pocketing. On the left, you see hole pocketing. On the right, you see hole profiling. And over here in the dialog, it works very exactly the same way as other cutter comp and other 2-axis operations. Just turn it on, and when you post, now I do want to make a mention of the post for cutter comp. Cutter comp does have to be set up in your post in order to output the G40, G41, G42, etc. In your G-code file. So if you're posting and you're looking for it and you don't see it, just contact us or send us your post definition file, and we'll add those criteria to it and send it back to you. Okay, so this is one of the main things in 2 1/2 axis milling. Let's go to the next one. I think I have another 2 1/2 axis. Yes, we have enhancements to our thread milling feature. This is actually a rather popular operation type. People wanting to cut threads either in holes if they just have a tap drill or a single pitch tap drill. You can use either one, and you can cut rather large hole threads, both internal and external threads. But if you look on the left here, you'll see the parameters that we enhanced and added to the thread milling. The start depth is interesting because if you want to leave such like a relief depth before the thread starts threading, you can use the start depth, and the threading will start obviously at the depth that you specify. So it'll start at the start depth, and then it'll go down to the hole depth, the thread depth, sorry. And we also added for thread pitch control. You can now specify threads per millimeter or per inch based on the units of the part that you're working on. And then also a cool one, number of starts. This will ensure that you have a number of full threads. And correct me if I'm wrong on this, Joe. The number, if you have one start, you'll have a thread that goes 360 degrees. It may be broken up into 180 and 180. But if you have this set at 2, you'll have another full thread. Excuse me, another full thread. And if you have it set at 5, obviously you'll have 5 threads. So you have more control, basically, on
so basically the start angle will determine the first start, and then 360, the full 360 will be divided by the number of starts to give you additional threads.
Mm-hmm. And that's basically it for thread milling. Yep. Okay, let's go on to the next, see what we got here. Okay, so we got a lot of enhancements. 3-axis milling, obviously, because 3-axis is the most used toolpath methods that we have. And initially what we've got here is we've added toolpath optimization. Toolpath optimization tab up here, and if you look down, you have feed rate reduction factors, feed rate reduction parameters. Now these feed rate optimization parameters, we did have them in the product, but it was only after the fact. In other words, you had to go into the toolpath editor and apply feed rate optimization to a toolpath after you have generated it. And then if you generate it again, then you would have to go back and add them again. So we modified this and moved the feed rate optimization up into each of the toolpath operation dialogues that supports it. So basically all 2-axis, if you have any linear toolpaths in 2-axis, you can apply feed rate optimization. Also in 3-axis, all of the linear 3-axis, any of the 3-axis that cuts in levels, you have basically, you look on the left here, we got one level here. This is facing, obviously, but any 3-axis that also is similar where you're cutting in levels and you have a toolpath on a flat plane that's wrapping around corners, you can apply the toolpath optimization parameters. So if you look at these dialogues, let's take a moment to look at these pictures we've got here. So on the left, we've got the toolpath optimization, feed rate reduction parameters. Okay, so currently, if you look at these two parameters right here, where you see, let's see. Hold on a second. Okay, look at my feed rate.
The most important parameter is the corner angle.
Yeah.
So depending on your corners, so the idea here is when you hit a corner, if your machinist wants to slow down the feed rate, then this is where you will set the corner angle. So if you have a 90-degree angle, anything steeper than 90 degrees in those corners, if you want to actually slow down the feed rate, you'll specify that angle, corner angle here, set to 90 in this dialog. And then, of course, the distance where you want to start the feed rate reduction. Where do you want it to start? So if it's a linear motion coming into the corner, we break up that linear motion based on that distance you specify, and then apply that feed rate. So again, after the corner has been cut, when do you want to reset the feed rate back to the normal feed rate? That's the next parameter. So yeah, these are the controls we have. And then obviously the feed rate reduction percentage. How much do you want to reduce the feed rate as you're going into the corner, and then ignoring certain types of motions also. So quite a bit of control. And we see this as an area that we're going to be constantly working on to improve feed rates and other sorts of optimizations for the toolpath in the coming releases.
Okay, thanks, Joe. What I was getting at is the feed rate reduction percentage. You see this is set at 0.25. So if you look at the G code here on the right, we see with no feed rate optimization. So the cut feed rate was set to 10 in the actual the cut parameters tab, or in the feeds and speeds tab, excuse me. And then the G code in the middle is with the feed rate optimization applied. You see you have your initial feed rate of 10, and then when it approaches each corner, it drops down to 2.5 or 25%. So that'll do that through the entire toolpath and make those adjustments. And I did want to mention also, one of the main reasons to use this is to alleviate some of the stress on your CNC machine. If you're noticing a lot of jerking motions, especially at corners, yeah, that's because the CNC machine is wanting to apply the full cut feed rate for the entire path. And it has to stop at a corner before it changes direction. So that's the jerking motion you're seeing. So that's the main reason why you want to apply some feed rate optimization. It'll slow down right before it gets to the corner. It'll stop, it'll speed up after it turns the corner, and you won't see that jerking motion in your CNC machine. The mechanisms, the servos will last a lot longer. Obviously, it won't wear out as quickly. So that's another thing to take into account for feed rate optimization. Okay, this is one that a lot of users have run into, and what we're doing here is we're applying meshing parameters ahead of time, and then when we calculate some of the 3-axis operation types, it takes those meshing parameters into account. Joe, do you want to take over this and discuss what's going on the left here as to
Okay, yeah, sure. So what happens in our 3-axis toolpath methods is when we have a surface, when you're machining surface, we actually start out with the mesh. We create a mesh, and then once we generate the toolpath, then we do some internal math to refine the toolpaths to the actual surface. So if the starting mesh is not very good, then sometimes we run into these kinds of issues you see on the left. And these typically, I mean, don't happen all the time. So it's a very small percentage of cases this happens, but it can be pretty annoying if you suddenly in the middle of your large part that has hundreds of surfaces, you have one surface that's given you, behavior like this. So this has been annoying to some of our customers where you're doing some sophisticated work. So what we have done to improve that is to give more control to the users to actually set the meshing initial meshing parameters to get the toolpath computation started. And so one of the things that the users can control now is the aspect ratio of the triangles in the mesh. Aspect ratio is basically the length divided by the width. So if you have an aspect ratio of 0, it's going to use the default mesh. Whatever the default meshing that was being previously used is going to be used. But if you said the aspect ratio is 1, then the mesh triangles are going to be very regular. So the width is going to be the same as the height of the triangles in the mesh. So you're going to get a very regular mesh on the surface. And then you can also control the minimum edge length to control the number of triangles you're getting or facets you're getting in the mesh. So when we do we've done some heuristic testing on it, and then we have some data on what are the right things to set up, and we can share that with the customers. We've noticed, and depending, the edge length is obviously dependent on the part size. But the aspect ratio, typically, if you wanted regular triangles, you want to set it at 1. And when you do that, the toolpaths are quite a bit improved. But one thing to notice and one thing to be aware of is, you can take the performance hit here. If you set up your mesh parameters to be too tight, it'll create meshes that are quite dense, and you might get a great toolpath, but it might be just overkill for your application. So a word of warning there. So you got to be a little bit, you got to do a little bit of experimentation to see that. But what Don's going to be showing is the types of surfaces that this improves. This machine control actually improves the toolpath quality on.
Okay, thanks.
All right, Don, go ahead.
Okay, and on the right, you see the result. So basically, you got these jagged motions in here. I'm going to show you this part and see why it does, not necessarily why, but I'm going to show you in effect when it happens, and then we can regenerate that after you set the meshing parameters and get a really good toolpath. This is something that users have run into recently, and this is our method to make it a lot better. Okay, so let's go.
Actually, the problem, sorry, Don, the problem occurs only in one class of surfaces, which is rule surfaces. When you have rule surface where the one side of the rule surface is quite a bit different than the other side, particularly in this case that Don is showing. It's a twisted rule surface where the rulings are quite a bit different from one side to the other, and that's when you see these issues, and that's where these meshing parameters will be applied.
Mm-hmm. Mm-hmm. And again, we're going to show you that in the actual part coming up in a demo. Okay, here's an interesting one. In 3-axis, we provided the ability to use both surfaces and curved regions. And when you do that, you can, similar to the way, in 2-axis operations where you have a nesting perimeter, like you have an outer perimeter and an inner perimeter, and then the toolpath is actually between the two. And if you look at the picture over here, we're selecting one part surface in the part surfaces tab, and this is parallel finishing, 3-axis. And then over on the containment regions tab, we've added these curves, as you can see in orange here, that go around the base of this feature. So the result then is parallel finishing will only take place between those two areas to the perimeter of the surface, and then stops at the inner curve region. So this is something that if you have some complex features in 3-axis that you need to cut, this will come into play and help you out. A little bit more control in the 3-axis parallel finishing. And it's not, correct me if I'm wrong, Joe, I don't think it's just in the parallel finishing. Is that the case? It might be another as well.
It's in all 3-axis. It's on all 3-axis methods.
Okay, good. So, and again, I wanted to mention, if you guys got any questions, please add them into the questions tab in your dialogue, and we'll be looking at them in the background and we'll get them answered for you. Okay, so what we have here is 3-axis milling enhancements. So it's 3-axis drive curves and surfaces combination of geometry. So previously, in previous versions, you either did surfaces or you did curves. Okay, so if you was doing curves and you wanted to get the same outcome, you would have to select all of the curves around the edge of the surface, then all the curves around here, and it would figure that out and, you know, cut between them. So now it just makes it a lot easier if you're going to, you know, avoid features like this in 3-axis. Okay, here's a good one too in 3-axis. We've added corner cleanup loops. If you're unfamiliar with corner cleanup, so let's just look at the pictures here. Yeah, corner cleanup is actually in 2-axis, and now we're adding it in some 3-axis operation types. So I believe it's also already available in the cutting in levels in 3-axis, such as clearing flats on horizontal roughing, etc. But now we've actually added it to a toolpath that is not planar. This is one of our advanced 3-axis methods, 3-axis projection pocketing, where the toolpath is calculated and then projected in the z-axis down onto the part. So in previous versions, if you look on the left here, the result would be these sharp corners. Okay, so it would calculate the offset. Okay, and then it would project it down onto the part surface, and then you'd have these really sharp corners that could cause you, again, some jerking motion in the CNC machine. As the tool goes to those corners, it has to stop, change direction, etc. So,
and more importantly, there might be, if the corner is really steep, you could actually end up leaving material there because the tool is turning, you know, very dramatically there, and so these cleanup loops actually will go in and clean those material stubs that are sitting on the part.
Yeah, as you can see up here in the corner cleanup loop, you see that the loop, I have it set to outside. Okay, so the loop is extended to the outside perimeter of the corner, which Joe mentioned that adds some cleanup right here in this pass, you know, right there at the corner itself. But it also allows the tool, you know, to turn that corner without so much jerking motion on the machine, on the CNC machine. So that is 3-axis milling, and that is corner cleanup loops in 3-axis projection pocketing. If you don't see 3-axis projection pocketing in your 3-axis menu, this is a pro configuration operation type. So if you don't see that, that's the reason why you may be running expert or standard. If you need these types of machining methods that we're showing right specifically here, just let us know when we'll send you information about upgrading to pro. So again, just before I move on, corner cleanup loops and 3-axis projection pocketing. This is before on the left, this is after in the center, and then on the right we see the control in the cut parameters tab of the 3-axis projection pocketing dialog. Okay, we've made some enhancements to our adaptive roughing. This is a very popular method used a lot by users, and we've actually gone in and made some enhancements to this, and I'll just mention them real quick. Basically, in the part here on the left, 3-axis adaptive roughing we're applying this to these center spaces here that we want to clear out material with a high-speed toolpath, okay? So at each cut level, you'll see there's multiple levels. At each cut level, we're ensuring that we add the helical entry, a helical entry. There'll be at each cut level, there'll be at least one helical entry. And then also, if you look right here, if the area requires a retract and transfer, we add arc motions to the entry motion, and I believe it's also on the exit on the other end. You can't see it right here. But basically what this does...
No, the exit, so Don, no, there's no helix on the exits, but it's just, you could have a ramp exit. It's basically,
yeah,
you could have a radial ramp, not the helical motions.
Yeah, or you could just extract straight out. Yeah.
Yeah, I want to say something about the 3-axis adaptive roughing. You might not be familiar with this because most people, even when you buy a Pro configuration, you don't get it. This is a new technology product that we released a couple of years ago. This is quite advanced, so it's actually a separate. We priced it separately because it's quite advanced. It actually uses the in-process cut stock to determine where are the remaining materials to cut. And so it does a lot of processing, and it's quite complex, and it uses adaptive reasoning for actually creating the toolpaths. So this is really useful in the case of if you're doing a lot of mold work, complex parts like this, then this toolpath method is very, very useful. It reduces your cutting load quite dramatically, and also, even in the pockets and facing, even types of core and cavities in both types of situations. And it's a separately priced module. So if you're interested, we're actually marketing it a little bit better this year, starting this year. So if you're interested, drop us an email, and then we can send you some pricing information on how to add this. This can be added to any configuration, whether standard or pro or expert. So just want to let you know. Thank you.
Okay, and just a review here on the far right, we see the adaptive roughing dialog. On the Engage Retract tab, we have our helical ramp set to 15 degrees. The angle of the helical ramp set to 15 degrees. The radius, obviously, is 1/8 of an inch, and then it applies that to each cut level. So we ensures that it applies to each cut level. So each level that you're cutting, you're getting a high-speed adaptive roughing toolpath produced. Okay, so if there's any questions on this, go ahead and add them to the questions tab, as I mentioned, and we'll get to them. Here's another enhancement that users have been asking for this past year, and we have, myself, I've asked for it also. So we're getting it now in 2025. That is the ability to leave your stock allowance in planar surfaces of your part. Anywhere that you're going to apply a clear flats option, you can also have it leave the stock allowance in your clear flats. Previously, the stock allowance on the flat areas did not apply. So if you had the clear flats checked, it would put a toolpath right on that flat area and clear that off for you. Well, sometimes you may not want that to occur, especially in a roughing toolpath where the tool is already doing a lot of work, and it could be wearing, and it could leave some unwanted material or some witness lines on this surface up here that is supposed to be a very clean finished surface. So we've added this to allow you to add stock to the planar areas ahead of time, and then you can come in with a toolpath such as a flat facing operation with another tool and get a really good finished area. And this will apply to any of the areas that it calculates to be a flat. So in this particular picture part here, obviously we have flats on each corner here, and then we have a flat down here, and then we have a flat in the middle right here, and then also inside at the bottom. So there's a lot of flat areas, and each one of those areas will leave the stock allowance if you check this box here under the cut levels tab, down here under cut levels next to clear flats. Just check this box now and it'll leave material in those flat areas. We're going to be showing this part. All the parts that you see in here, I would say 90% of them, we're going to actually looking at the parts themselves in the demo portion. Okay. So that is 3-axis clear flats with stock allowance. Now in 5-axis, we have enhanced one of our operation types. So this would be the 5-axis curve projection. So let's look at what's happening here in this part. We have a 5-axis application where we're cutting around the edge of this complex surface here. And if you look at this edge in orange, okay, you'll see that it's at the base of a raised area, okay? So prior in 2024, if you wanted to add curve machining in this area, there's a chance that it would ride up on this vertical face as it goes around this complex area. So if that occurred, then obviously you would want to use another method to try to clear up these areas. So now what it does is it calculates the curve that you want to project and allows you to set an offset. So if we know the tool diameter on the tip of the tool is a certain diameter, you can offset that, say half of the tool diameter. Here I'm setting it to 2.5, okay? And it's what it does is it calculates the offset curve and then it projects it down onto the tool path. So you don't have to draw. If you tried to go in here and draw this offset curve, you would not get a good result because of the complex area this is in. Trying to offset it and then project it, it's going to be a problem. So you're probably not going to be able to use this method probably in 20 previous versions. So now we do this as part of the toolpath. It's very, very helpful, as you can see in this particular part itself. And this method is used on 5-axis application where you want to trim like material from the edges of the part, or you want to clean up material on the edge of a feature in 5-axis. So again, this is in 5-axis curve projection, and this is in the premium, our premium 5-axis configuration, where you have all of the 5-axis continuous toolpaths available to you. And this one applies to the curve projection machining operation type. And again, you got this additional dialog here in the cut parameters tab. It allows you to set the cut side, left, right, center, and then also an offset if you want to apply an offset value. So very, very helpful if you're cutting in 5-axis. Now we're going to go from 5-axis to hole making because we've added a new method, new hole type method, and that is called rigid tapping. Now, rigid tapping, if your CNC controller supports what we refer to as canned cycles, C-A-N-N-E-D, as in a can. So these are predefined cycle types in your CNC machine that you can apply as needed. So this is an additional cycle type that we've added. It is a G84 cycle. And what we're doing here is if you're unfamiliar with rigid tapping versus regular tapping, so basically the difference is in the tool itself. In rigid tapping, the tool is rigid. In other words, the holder, the thread, everything is one rigid unit. Okay, so the movement of the threading, the cut feed, and the Z-depth is all controlled in the spindle and in the cut parameters that you're outputting. Okay, I should back up and say that. I should reword that. If you're using the rigid, then if you look at the CAN cycle over here, it outputs the requirements for the controller to calculate the feed rate, the cut, and the
RPM is
yeah,
most
the
important, the
RPM.
spindle RPM.
Yeah. So in the regular tapping, the tool is actually a floating tool where it does I guess the tapping inside that floating area. But there's one thing you need to know about this. The rigid tapping is a lot more accurate. Okay, and but there is one thing you want to be concerned about. Because it's rigid, you want to make sure you got your parameters correct, because it puts more stress on the tap tool itself. So Joe, you want to add any more to that? I know it was kind of awkward explanations, but
No, go ahead. I think, yeah, it's too hard, too difficult to explain
yeah,
it by words, so you need pictures. So
okay.
Go ahead.
So let's just to recap there. In hole making, there is now multiple options for tapping, and I'll show you that one on this part. Okay, so you got a rigid tap, that's the new method, and then you had your previous methods, which was a regular tap, and we'll show you that. Okay, this is an interesting one here. So what we're doing when you define your machine tool definition, now we're implementing the min-max of the translational limits of your machine. So now you can enter these. Previously, it didn't allow these, or it didn't display the limits. Let's put it that way. And in 2025, we're displaying them. So if you enter your limits, check this box to display the translational limits, and it'll display that volume on the part itself. So what I'm getting at here down in this picture here, we see that the part is accidentally moved too far in the X direction, and it's actually violating the translational limits of your part. So you can see that visually, and then also you'll get an error message if your toolpath extends past this volume. So when you simulate it, you'll get an error message. So this is something that users have asked for a while now, and very helpful. I'll show you this part as well. So just as a review, machine tool definition: when you define your machine tool, define your translational limits. Every CNC machine has these limits. You just look them up in your manual to just determine what those limits are in X, Y, and Z, and you can add them here, and you can just display them on the part. Okay. Now, we've added a lot of small usability enhancements. So we picked out a few, 10 of them to be exact, and we're going to talk about them. But then again, just keep in mind, these are only a few that we chose to talk about. There's a lot more in the What's New document, okay? So I labeled them here, and I listed the definitions here 1 through 5, and we'll just talk a little bit about them. Number 1 is the machine coordinate system triad, or the work zero. We've just enhanced the work zero now to look a little bit different than the world triad. So you won't get confused now on, am I displaying the work zero or am I displaying the world coordinate system? So you'll get a better idea with the different, just a graphic display of the triad itself. Now go over to number 2. This is a good one here. Now you can set the tolerance for simulations separately from your cut parameters tab or whatever in the operation dialog itself. Okay, so now you can set the accuracy of the simulation separately. So if you have a large part or just a regular part, and you see that you need a little bit more accuracy in the simulation itself, you can just tighten this volume up, this value up, and rerun the simulation, and you'll get a more accurate display of the simulation itself. Transversely, if it's taking too long to simulate, you can relax this tolerance and you'll get a much faster simulation, but just bear in mind it's a little bit less accurate. So you can control that separately now. Let's see here. And also, there are two options here. If you're in the Express configuration, you don't have the polygonal simulation model, you only have the voxel model. So if you're in the Express, you'll see this value down here at the bottom. You specify spacing for voxel model. If you're above Express, you get the advanced polygonal model, and you'll see this value right here. Okay, and you can also adjust the slider, similar to in previous 2024 and prior products. You can also adjust it here. But this gives you an extra control for various reasons, whether you want it more accurate, you want to slow down or speed up the simulation, or et cetera, et cetera. So that is under simulation tolerance, and that is in the simulation tab of the CAM preferences dialog. Okay. Again, if you got any questions, I know we're going over a lot of material, but we're gonna be going probably a little bit past the hour, so we can get in and look at each of these parts as well. So hang with us. So number 3, we're looking at, this is something that many users have asked for. If you've ever gone into your machining job tree and you've copied an operation or you've cloned an operation, you would have noticed that this was appended to the toolpath name, -copy. So every time you copied it, you'd have -copy. If you copied the copy, you'd have -copy. So it just gets very time consuming to get in there and get rid of these extra text that's in the name of the toolpath. So now what we've done, we've allowed, giving you a control method of just eliminating that completely, or you can append whatever you want to append, and then also you can append an increment number. So basically, let's say you kept the -copy, your first one would be -copy, your next clone one would be -copy number 1, and then your next would be -copy number 2, 3, et cetera, if you want to use the append number. Or again, if you don't want to see it at all and you just want to copy with it being the exact same name, you just uncheck these, and that'll take care of that for you. Again, this is something that's been requested quite a few times over the past year, because people use, our product is very has usability built in, so you can copy and paste operation types as you need them, but now it gives you the opportunity to define the name a little bit better of those copied operation types. So that is number 3, copy cloning naming conventions. So let's look over here at number 4. We've also on the post-processing tab, you can't see the tab here, but the post-processing tab of the CAM preferences dialog, we have these options now broken out to save the post to a file, or always load the post from a file when you open it. Okay, so those are broken out separately now. And then just to retract here on number 3, this is the user interface tab of the CAM preferences dialog. Okay, so this would be number 4, would be the save post preferences that we've broken out, okay, onto the post-processing tab of the CAM preferences dialog. Number 5, reset preferences. This is very handy if you've made some adjustments in your CAM preferences. There's a lot of tabs here that you can adjust, as you see them up here. and now things are not quite going the way you want them as far as the default operation of the CAM module itself. Now you can back up and say reset to my defaults, so it'll reset it to the factory defaults that were used when you installed the product. It's very, very, very helpful for you to use this if you need to. Okay, so let's see. I think I have another slide for usability. Yeah. So this is number 6 through 10, and I have them listed here. So number 6, we've added some enhancements to the select post-processor dialog. And this is a dialog where you have your drop-down selection of your current post-processor. We've added a couple enhancements here, okay, that allows you to automatically set it to the default folder. So if you've gone in and you've adjusted this folder to load post-processor files from, okay, if you pick this little button here with 3 dots on it and you went in and you changed it to where you thought your post was, and then you realize, well, your post isn't there, it's actually in my install path. Now you can just pick this button and it'll automatically change it back to the default location of the folder where to load post-processor files from. So this will be very helpful if you need to use it. And then also this one is very, very helpful here. Copy any modified post from my previous version. We have a lot of contact with support department about, especially when users install a new update, okay, they lose where their posts are. In other words, they may be using a modified post that they've used for years, okay? It's been modified several times, so they want to use that same post. But they may have copied that post or used it from the install path of the previous version, okay? This option right here, excuse me for those pop-ups, this option right here allows you to copy any modified posts from a previous version. It'll go and grab them, and I guess it'll copy them in the install path of the new version. Correct me if I'm wrong, Joe, but I think that's what's going to happen there. So it'll just make sure that you have them, less support calls. You can get to work right quickly after you do an upgrade, and you won't have any problem with your posts. Now, number 7, enable, disable information dialog. We have had this request for quite some time. Maybe not in all of them at one time, but at one dialog or the other dialog, people don't want to see the dialog. I mean, they understand what the dialog means, but they don't want it to pop up every time and have to do another click, to close it or to turn it off. So we've now provided a section in the user interface tab of the CAM preferences where you can control pretty much 90% of the dialogues that pop up. You can turn them off or on here from this portion of the dialog. Okay, and that's very, very helpful. As you become more familiar with the product, you know what these pop-ups mean. Yeah, I understand it. Let's just turn them off for now. So you can do that here. That's number 7. Number 8 is another very helpful enhancement. Maintain order of control geometry region. So in each of the toolpath methods, you'll see that you have your area where you can select your control geometry, be it part regions, void regions, et cetera, et cetera. Now, previously, you may have thought that they were processed in the order that you see them here, but there's a lot of processing going on in the background, which causes that maybe not to be the case. So Joe, you can jump in here and correct me if I'm wrong.
Yeah,
go ahead.
Let me go ahead and explain this. Yeah, let me explain this. So previously in profiling, let's say you selected a bunch of curves. There would be a lot of pre-processing that happens to those curves. What we typically do is we check for self-intersections. We check for endpoint matching curves. So if there are two curves that are endpoint matched, we actually merge them into one internally. And then if they have self-intersections, we actually attempt to remove those self-intersections so the the toolpath methods will work correctly. So there's a lot of pre-processing that happens. And even sometimes we refine some of the curves if change the tolerance on the curve sometimes to make things simpler or more refined for the toolpaths. But if now with this maintain order of regions, if you check that box, we are not going to touch those curves that you input. So all those curves that you input are going to be treated separately and independently, and they're going to be treated as single curves, and each of them will be cut independently. So people have asked us this, especially people who are creating geometry that is clean, and they want to maintain the geometry that they create for the machining operation. So this is why this button was added.
Okay, let me ask you a question while we're on this, Joe.
I think we need to move on, Don. So because we're almost at the 1 hour mark, so we still got the demo to show.
Okay. So that was maintain order, control geometry. Number 9, we mentioned this about the clear flats and the add stock. We've already talked about that. Number 10, add stock allowance to island tops. This is similar to the add stock in 3-axis, but this is in the 2-axis methods where you have the clear island tops method. The clear island tops option. So you can add the stock there as well. Okay, Joe, you want to review these post-processing enhancements real quick?
Yeah, I want to go through this real quickly because we are almost out of time, and I don't want to keep people here that might have other things they want to do. So we really need to get onto the demo.
Okay.
There's a bunch of changes that have went into the posts. We've added new post variables. Since we added rigid tapping, there's a new cycle that was implemented in the post. And then all the machine tool parameters that are now you've defined in the machine tool dialog are now transmitted to the post. So you can use that, the post processor generator can use that in any fashion it deems necessary. And then our programmable post engine also was enhanced to handle asynchronous writing, which means we can post everything and then write to a file. This is very, very useful, especially if you are writing to different format files, not just G code. In fact, we can now write to DXF files as the post processor engine. So it's very, very sophisticated now with the ability to handle asynchronous writing. And then new methods to access machining operation types. This helps us post different operations in different manners. And then enhancement to suppress the work offset code from being posted. That's also been added. And then also any toolpath error events were also added in the programmable posts. And this can trigger other things in the programmable post that the user might want to do. Okay, the next slide, I think, is the SDK slide. For those of you who are not familiar, we do in the RhinoCAM product, we support an SDK. In this release, Python 3 was implemented, support for that. Previously in 2024, only Python 2 was implemented. Some of Rhino itself had gone to Python 3, and so some of the users were having issues with the scripts not running correctly. So we have added the implementation support for Python 3. And then again, new method to transmit machine tool parameters to the SDK was also sent, so you can do your own, processing of the machine tool parameters. And other things, other API calls were added that people have asked us for. And the way we work on the SDK is when somebody's using the SDK and they need something, they ask us, and we add new methods so we can get them going, because not many people use the SDK at this point. And number 4, that's an important one. We turned off all the interactive dialogues when an SDK is running, or SDK script is running, because if you want to run it lights out, you don't want manual intervention if there's an error, and you just want to cycle through those errors and run the next operation or next command in a script. We allow that to be done now. Any errors will be written to a log file. And then we have updated the SDK document with additional user examples as well. So
Yes, that number 5 have been asked by users for more examples.